This is a Queen Mary's College video. We're going to be looking at complexes. So the questions we'll be looking at and answering is, what is a ligand? And what is a complex? And what do we mean by coordination number? A complex is made up of a central metal atom or ion, and the ligands are attached by dative covalent bonds. So looking at the metal that's used to make this complex, it's normally a D block element. So to remind you, there are the D block elements in the middle of the periodic table between group 2 and group 3. We generally focus on the first row, so those D block elements from scandium through to zinc in blue there. So that's the metal. The ligand is just a molecule or an ion which has at least one lone pair of electrons. So molecules like water, ammonia, or ions like chloride ions are ligands. So let's take a look. There's the water molecule. As you can see, there's a lone pair on the oxygen, so that makes it a ligand. Ammonia, again you can see the lone pair on the nitrogen, so that makes it a ligand. Chloride ion, a negatively charged ligand, lone pair, as you can see on the chlorine there. So the chloride ion is a ligand. And hydroxide as well, lone pair on the oxygen. So all are ligands. So let's take a look at an example of a complex ion. Let's start with copper ions, copper 2+ ions. So the charge on the ion is 2+, so that's our metal. And the ligand is going to be water molecules. So in fact for this complex we've got 6 water molecules. So these together form a complex, showing the copper first there, and a bracket around water, and the 6 water ligands. Outside the square bracket we put the overall charge, the 2+ charge. So when you've got copper 2 ion and 6 waters which are neutral, the overall charge is +2. So the +2 is due to the copper ion involved, and the water is neutral. So overall a 2+ charge always placed outside the square bracket. So the dative covalent bonds are formed between the ligand and the metal. So just to remind you of the definition of dative covalent bonds, where the atoms of a bond, both electrons come from one of those atoms to form the shared electron pair, shown by an arrow going from the atom that supplies the electrons. So here's that same complex. We've got copper 2+ in the middle, but we don't show the 2+, we just show the symbol for copper. And it's surrounded by 6 water molecules as ligands. And we show that lone pair very clearly on the oxygen atom of the water molecule, and the direction of the arrow from the lone pair to copper. Those electrons simply fill up empty copper orbitals. Another example, let's use the iron 2+ ion as the metal. Again we'll use 6 water molecules, 6 water ligands. So much the same, the iron is first, then the 6 waters, and the overall charge 2+ again outside the bracket. Since of course water is neutral, there's a simplified diagram showing the complex there. Overall charge outside the bracket. Here it is again, neatly showing the oxygen's lone pair of the water molecule. If we can go to some trouble to make sure that the lone pair on the oxygen is facing the metal. It is possible to get a neutral complex. So if it's neutral, we just call it a complex. If it has a charge, we call it a complex ion. So let's take a look at one that doesn't have a charge. That's nickel atoms with a different, an unusual ligand, carbon monoxide, CO, lone pair on the carbon. So 4 of those ligands gives us this neutral complex. So the nickel first, then 4 lots of the ligand there, and overall charge 0 as we said, so a neutral complex. We looked at the ligands earlier, and one of them was a simple ion like the chloride ion. So here we can avoid the use of brackets in the formula. So if we've got nickel 2 ions and 4 chlorides, we don't have to put the chloride in brackets. Each chloride ion is single negative, so 4 of those is a total of 4 negatives, and then the 2 plus on the nickel 2 gives an overall charge of 2 minus, always shown outside that square bracket. Coordination number is a term that we use to state the number of dative covalent bonds in a complex. So it's the number of dative bonds formed from the ligands with their lone pair on one of the atoms to the central metal. Not to be confused with the number of ligands. So it's the number of dative covalent bonds. So you can see in the first diagram here you've got the copper water complex, and so there are 6 dative covalent bonds, so the coordination number is 6. And here we've got the nickel chloride complex, and so you've got the 4 dative covalent bonds, so that coordination number is 4. So the coordination number is usually 4 or 6. The maximum is 6, since no more than 6 ligands can be arranged around any metal. Here are a few more complexes where there are 6 dative covalent bonds, so the coordination of all of these is 6. Here's an unusual ligand, C2O42-, formula. You may recognize the ethanedioate ion formed from ethanedioic acid, a dicarboxylic acid. So this is the 2-carbon dicarboxylate ion. And as you can see, there's a lone pair of electrons on each of those oxygens. So this gives us a ligand, but in particular it's a bidentate ligand, because it can form 2 dative bonds with the metal. So it's a ligand that can form 2 dative bonds to a central metal atom or ion. So let's say we've got iron 3+ ions with 3 of these bidentate ligands. What would be the formula? Well, putting the metal first and then brackets, you've got the ligand, 3 lots of those. So overall, adding up the charges, hopefully you agree that it's 3 minus. There's a diagram showing those 3 bidentate ligands and the charge outside the bracket. You can see that the coordination number is 6, since there are 6 dative bonds altogether. Another example is chromium 3 ions, and we'll have 3 of those bidentate ligands again. So let's put together the formula of the complex ion. So again, metal going first, chromium, then 3 lots of the ethanedioate. So again, if we can work out the charge overall there outside the bracket. So well done if you got -3. 3 minus there. So there's the structure of the complex, coordination number 6. 6 dative bonds from those oxygens to the chromium. Another example, copper 2+ ions, this time the same 3 ligandentate ligands. So hopefully you agree the overall charge outside the bracket is -4. 4 minus. And there's the structure of the complex, this time showing the lone pairs very clearly. Overall charge 4 minus outside, so 6 dative covalent bonds involved. So coordination is 6. Polydentate ligands can form many dative bonds, so one ligand can form many dative bonds so long as they've got more than one lone pair. So we can talk about a hexadentate ligand. So an example of that, EDTA, which has a 4- charge. We don't need to worry what it stands for. It's an old naming system. But there's the ligand, EDTA 4-, so 6 lone pairs makes it a hexadentate ligand. So the lone pair is on the oxygen with the negative charge, and a lone pair on the nitrogen. So one ligand molecule can form a complex with a central metal ion. So in this case, let's take a look at one EDTA ion ligand with copper 2 ion. And the formula showing the metal first, copper, and then the bracket EDTA is sufficient, and then close bracket, and the overall charge copper 2+ with 1 EDTA 4-. Overall is 2- charge. And here's the structure. You can see those 6 dative covalent bonds. There's one EDTA molecule ligand wrapped around a single copper 2 ion, all charges outside the bracket. You wouldn't be expected to draw this structure, just the formula. Make sure you know which of the 6 atoms involved are forming the bonds, so lone pairs on those 4 oxygens and those 2 nitrogens. Let's take a look at the shapes of these complexes. So there is a revision video on the shapes of molecules from last year's work which you can look at. You'll remember that the number of electron groups involved around the central atom repel each other and move as far away from each other as possible. If we take a look at complexes with a coordination number of 4, there's 2 possible shapes. So from last year you'll remember the tetrahedral shape, which has a bond angle 109.5. But for complexes we can also have the square planar shape with a bond angle of 90 degrees. So here are the complexes from before with coordination number of 6. So these are all octahedral complexes with the bond angle 90 degrees. And here's the iron with bidentate ligands, 3 lots of the bidentate ligands. So again, coordination number is 6, octahedral complex, bond angle 90 degrees. And the EDTA complex with copper, again, coordination number is 6, bond angle 90 degrees, octahedral shape once again.